So good morning everyone. I hope all are doing good. In this lecture we are going to discuss a very important topic, a regular expression in formal languages, or you can say automata theory. The regular expression is a way of representation by which we can represent a formal language, or we represent regular languages only. So we write the regular expression to represent regular languages, right? So they are used to represent formal languages. Regular language consists of literals, concatenation, alternation, repetition, grouping, character classes, and escape sequences we can represent in the regular expressions. So what are these? One by one we will understand. Regular expressions have various applications like in text searching or data validation or lexical analysis, or a number of other uses are also there. Okay. So like, what is a literal? You already know that it is a kind of character, individual character, which represent itself. So if I write a small a or a small b of a number of things, that we consider it as a literal. So if I am saying a set of alphabet is having two symbols a and b, so that means I am saying a and b are two different literals. Okay. Concatenation means if I string w1 is there, which is having, let's say, ab, and w2 is there, which is having, let's say, a b, concatenation w1 dot w2, it will sequential arrangement of these two strings. Alternation means there is a pipe symbol. So if I write a or b, in some of the languages we can write the regular expression like this. It is means either this or this. Okay. Then repetition. Repetition means if repeatedly I want to write something. So if I want to write either a 0 times or 1 times or a number of things, it depends how many times I want to repeat. So in, let's say, I write the regular expression in Linux, and if I write this question mark over a, that means a can occur either 0 time, that means epsilon, or a can occur 1 time, that means only a to the power 1, that is a. If I write a to the power like this positive closure, you know that the meaning of this is either single times a or 2 times or any n number of times. If I write a cleans closure or star, that means epsilon, single a, or multiple times a can occur, right? So this is the repetition. Now what is grouping? We generally use the parenthesis to group the number of literals. So if I want to write like a language have consecutively two A's, so I write A and I group them, and let's say something like that. So grouping is this. We may group n number of characters. Then character classes. If I want to represent a single place, and in this place if I want to write, this single character can be either A or B or C or D, then I can write inside the square bracket. So if I write the same thing with this this bracket, or if I write A, B, C, D, that means it is a grouping. Altogether A, B, C, D must come in a sequence. But if I write this square bracket A, B, C, D, that means there is a single place where either A can come, or B can come, or C can come, or D can come, kind of thing. Okay. So that is character class we can define. Escape sequence, if let's say there is a space or dot or something which is already having some other meaning, if you don't want to consider that particular meaning of that particular character, then you put this backward slash. But we use these things in programming languages when we are writing the regular expression in C, when we are using a specific tool like lex. So we write the regular expression for lex also in order to design different tokens. And if we are writing a regular expression in Linux, then also we use all these things. Okay. But when it comes to the language, like the formal language in your book or in the gate exam, many of the things we don't use. We use very easy form of the regular expression. Okay. So we use only four things. We use concatenation, so let's say dot operation. Generally we use let's say we use repetition, we use either star or plus, and we use or operator. So there are two plus I am writing, This is I'm saying like or. This is I'm saying positive closure, right? And this is cleans closure. You know that, right? And this is concatenation. So generally we use these three and we write our regular expression. So let's say if we have a language, and in the language there is a pattern which every string is following, because language is the combination of a string, and because we cannot write all these strings, we need to represent a language in terms of writing the pattern. You consider a situation like this. Let's say you are going to pick someone, and the task has been given by your boss, let's say, and you are going to pick a guy, and you are not aware about the guy, you never met him, but your boss is trying to clarify you. The guy will have, like, he will be wearing blue shirt, or maybe his hairstyle will be like this, he'll be wearing specs, or a number of attributes the boss is clarifying, so that you can easily identify कि किसको लेने आए हो आप एयरपोर्ट पे, राइट? सो that kind of declaration we write like pattern, specifying the pattern so that someone can match the pattern and identify the things. The regular expression does the same thing. So if I'm saying there is a language in which every string is starting with small a, where the set of alphabet is, let's say, a comma b. So if a language is there which is having every string is starting, so let's say I'm saying every string is starting with a. So if this is the language, the regular expression, if I want to write here, it is re. Here I am writing language, right? So this language is this, and if I write the regular expression, I can write a, and after a there can be a or b asterisk, right? So either a or b, any combination can come after that, but the first character is fixed. Okay, so if I say there is another language too where every string is ending with a, that means I can write a is fixed in the end, but before that anything can come in the sequence of a or b, right? If I say there's a language L3 which is, let's say, which does not have any string, empty language, for that the regular expression we will represent as a 5. Okay, and let's say if we consider that a language 4 is having all these strings over alphabet a comma b, right? So if all these strings over a comma b L is having, so if I write L4, the regular expression for L4 will be a or b, but if I'm considering all, that means it will be cleans closure or start. Now if I consider L5, let's say there's a language where the starting and ending is fixed, so all these strings are starting with 0 and with a, because alphabet is a comma b, and ending with, let's say, b. So if this is the language, the regular expression of L5 will be a starting, b will be ending, in between anything in terms of a b, right? So if I consider there's a language L6 where every strings, or you can say all these strings with at least 2 length, all these strings of at least 2 length. So all these strings of at least 2 length, the regular expression of L6 will look like, we need to represent 2 places. At least 2 length, that means the very first place is not defined, okay, but it can be A or B because alphabet is, I'm considering AB. And second place is also not fixed, but it can be either A or B. After that, A or B star we can write. So after that anything comes or not, but at least 2 character need to be there, right? So let's say if I say L7 in every strings, let's say A must occur. All these strings must contain 1A. So if 1A is compulsory, the L7 if we represent, we may write A is compulsory. Before that A or B anything comes. After that A or B anything comes. Right? So I hope you can understand how we are utilizing the regular expression to represent the different languages. So we will continue the discussion in next class also on regular expression because it is very important topic. We try to cover almost every possible language in this. So I'm closing this lecture for the moment. See you in the next class. Thank you everybody for connecting.